So in problem number 434, they ask you to take the exponential equation, x equals 3, and kind of justify why that's the same as 10 to the 0.0086x equals 10 to the 0.4771. Right, and it seems very obscure. Like, why are these numbers the ones that we are using in the exponents now? And the whole thing has to do with the fact that logarithms are exponents, right? So keep that in the back of your mind. Logarithms are exponents. So if these are exponents, most likely they actually came from logarithms, right? So let's just double check that. Take your calculator and do the log base 10 of 1.02 and the log base 10 of 3. And you should get those two exponents because logarithms are exponents. So remember that, okay? It is important to kind of think about how you can go from one to the other. So if we take, let's see, log base 10 of each of these to the x, and you can do this because you can do whatever you want as long as you do it to both sides of an equation. So that's not a problem, right? So then you could say this is 0.0086 to the x and 0.4771, right? Because we figured out that we can substitute this for 0086 and this for 0.4771, right? The next thing you can do to both sides of an equation is exponentiate. The word is exponentiate, which is raising both sides of the equation to a number. So I can take 10 and raise it to this, to the x, and I could take 10 and raise it to the 0.4771. So now we're kind of at the same place, but the only thing that is missing is this is to the x power as opposed to the multiplication. And you can try and figure out why that works. Why can you go from 10 to the 0.0086 raised to the x and make it 0.0086x?